I would like to tell you about our pilot project on tri-stereo that we acquired from Pleiades satellite. It was a joint project by Technology 2000 and Racurs. And here you can see the overall plan of presentation. First I will tell you about the accuracy assessment after alignment, and after that Nadezhda Malyavina, the head of our production department of Racurs, will tell you about interpretation, 3D modeling, and mapping. Now I see. Well, can you see it now? Okay. Yes. Now I think you see the plan of my presentation. First part of it will be covered by me, and the second and third one will be covered by Nadezhda. I will start from the geometric model overview, which we tested there. All these models are traditionally split into three categories: rigorous model, or the one that Mikhail called physical or full universal model, and then replacing models which are usually RPC based, like this an approximation rigorous model. Rigorous model is in reconstitution of the configuration or directions of rays that the image is made up of. It gives a maximum accuracy of image orientation. The main restriction or limitation to its use is the availability of all the necessary information and metadata, like the elements of internal orientation. In the case with Pleiades, all these data are present in the metadata, but in October 2012, the company Estrium Geoservices published a press release that they have greatly improved the procedure of approximation of the rigorous model using RPC, and the new model or new method of approximation that they use can provide much higher accuracy of model approximation. Geometrical difference between rigorous model and RPC now is very little. And in terms of, first of all, it is much easier to work with RPC, and secondly, most of the projects which are implemented on satellite imagery are ortho rectification, ortho realignment on the altitude or elevation matrices, which can be done with RPC by applying a direct formula by using Earth coordinates, and we can project them on the image coordinates, which is more efficient. And also RPC is quite justifiable, because if in the same block we have images with rigorous and RPC models, then we have to make them compatible. And in recent years, especially when we speak about images with super high resolution, metadata contain RPC mostly. If we used rigorous model in this merged block, still as a result of block realignment will go back to RPC anyway. And this project that we are telling you about to use RPC. RPC had two adjustments: one a simple adjustment like bias removal, and a fine refinement. Speaking about universal models, they are based on computation of coefficients based on ground control points and no use of metadata. It can be justified in rare cases. For instance, sometimes it is the system of coordinates where this GCPs exists is unknown, and we need to use the same system of coordinates for the output product, and to establish parameters is hard sometimes for one particular purpose. And in that case, it is impossible to use metadata that RPC is attached to RGS 74, and then we'll have to use a universal model, although it's still better to avoid it. Here you can see the parameters of the used images. Here you should pay special attention to the fact that here you can see that they had been acquired from a single pass. You can see it from the date of acquisition, and the difference between the nadir deviation is not that much. So the acquired stereo pairs, as we will see later on, will have very low Benach component. There was a bundle product and separately panchromatic, separately multispectral images. To do this project, we also did pen sharpening. Pen sharpening was done at the stage of adding these images to PHOTOMOD. We used PHOTOMOD at the input stage. It's not always possible, unfortunately. Sometimes we have to do orthophoto, do pen sharpening later, but as far as Pleiades are concerned, it's much easier and user-friendly. So it is an easy and labor unintensive work. Next, ground point set. These points were provided by the company Technology 2000, and I can tell you that this set of point set was quite haphazard, both in terms of the accuracy of coordinates on ground, and the sources of this ground control points were different, like field studies and scanned topographic plans of different scale. And as you can see, the RMS of those points was sometimes 5 times different for different sources, from 20 centimeters, like in field points, and digitized topographic plans. And after digitization, again, there were a lot of deviations. On the top, you can see 2 images with well-identifiable points. On the bottom, you can see 2 fragments. These are the points which are very hard to recognize, like the one, like the left lower one. Our production committee didn't do any rectification for that, so basically not all points were easy to recognize. The specialists of our production unit assessed the average precision or accuracy of the measurement at the level 1 pixel, which on the one hand can be not so accurate as can happen, but in general, the main value of this project is that it was done under ideal conditions, but under field conditions. Very rarely we have projects which are implemented in ideal circumstances. Here we have a case closer to real production activities or environment. Here you can see a table of our research with the enumeration of experiments implemented there. And in principle, to the right, in the right, you can see the type of experiment and with its goal, and they're subdivided into groups and color-coded. The first groups, the first and second experiment, were about identification of the achievable accuracy without the use of GCP, and the third experiment was when we have only 1 GCP. Next, green group, fourth and fifth experiments are using the number of GCPs which are usually sufficient and optimal for rectification of image on RPC. Then the yellow group, sixth and seventh experiments, are about identification of whether we can increase the accuracy with a greater number of GCPs, and then with its comparison with the achievable precision using universal methods. The 8th and 9th experiments are about assessment of how well the model RPC plus minus shift to bias or a fine refinement are appropriate for this image modeling, whether the precision would be good, whether this model can be overlaid on this background image. And the last one was the evaluation of maximum precision achievable by these universal models. And first we took 3 separate images. The results acquired were quite close. For instance, one of them here. What is typical here is that in case of the first experiment, when we use only RPC without the ground control points, we had about 4 meter deviation, which is in line with the S-stream specification, where they had to have this, so it lies within the specifications of I-stream. Next, we see that with the use of at least 1 GCP, we already achieve the accuracy of 0.8, and with the increased number of GCPs, with the fine refinement or bias adjustment, this accuracy remains the same. So if we look only at this table, we can make a conclusion that such adjustments as bias or a fine refinement with one GCP only we can get a good accuracy, despite the fact that the Pleiades products are supplied in 0.5 meters, but their raw resolution is 0.7, and they do resampling for it. The actual sensor on the Pleiades series has some curvature to reduce aberrations. They do this, and all of it is closer to a raw image resolution. But I'd like to tell you that Mikhail warned me against generalizing these results, because indeed the efficiency of this bias adjustment depends on the roll angle difference, and in some cases 1 point like bias would not be enough, but in this set of data it worked well. And as far as the universal methods of the last group are concerned, they provide quite typical results, some a bit worse than RPC. This is yet another standalone image, similar results, and these are the conclusions that I've voiced already. Let's not waste more time on them. Next come triplets. Speaking about triplets, when rectifying under this experiment where they were rectified by triplets, not splitting them into stereopairs, for each point which was measured on 3 images, 6 collinearity equations were made, which were resolved then in the system. This is a simultaneous work for 3 images at the same time. So we can see here that on this triplet we didn't measure the type points. We had only GCPs, but all GCPs participating in this experiment were measured in all 3 images. We see that without the use of GCP, we have about same 4 meter in mean and 2.5 meters backwards accuracy, and then when we use GCPs, the plane accuracy becomes the same level as for a single or standalone image, but the vertical accuracy remains about the same. In the 7th experiment, the accuracy became worse a bit with the increased number of GCPs, but it perhaps is related to the fact that after all of this has been done, I learned that these points were not of the same accuracy, and just with the growing number, perhaps there were some points with lower accuracy, and that's why the accuracy of rectification went down. Here we can see big deviations on the vertical plane, especially when using universal methods, and this situation can be called simply that universal methods for stereoscopic processing are not really applicable here. Here we can see the results of rectification with type points. They're a bit better, but not considerably. The differences are usually in the less number to the better, but not really considerable. Again, with universal methods, the situation remains the same. Here you can see the conclusions. We see using supplied RPC and the GCPs, the achieved planimetric accuracy was 3.6 meter RMSC. In the case of involving the points, and 3.8 meters without them. The results, as we can see, are a bit worse than what Mikhail was talking about. Perhaps here we have 2 reasons, or 3 reasons for that. The measurement of those points on images and the coordinates, which were not always convenient or reliable for current control point, and the accuracy of GCPs was much worse compared to what was used in IGN. And another thing, we had a lower BNH quotient. Here you can see the comparison of triplets with stereopairs. Here you can see the results for triplets, which we saw already earlier, and their ratio of basis to height, B and H ratio, 0.37. It is already quite a low ratio, because for stereopair this B and H should be 6 to 8. And we found out later on that SGM company doesn't have specifications which would have minimum ratio of B and H stereo even for 3 stereo. So there could be big variation, and when ordering an image we need to pay special attention to that. Here you can see the results for stereo pairs in front and backwards with the same results as triplets, and then we have stereo pairs with worse B&H ratio. Here they have 0.25 B&H ratio, and we see that the accuracy is going down. And the third stereo pair has a B&H ratio of only 0.1 plus, and its accuracy is even worse. This is a natural result of the low B&H ratio. Here you can see it's written right here. And I would like to give the floor to Nadezhda.
Добрый вечер. Я продолжу рассказывать про исследование снимков Плеяды.
Hello. I will tell you about a 3D modeling done by Racurs and about accuracy properties that were assessed by the company. Mr. Sechin yesterday told us about dense 3D models obtained from various sources, including Pleiades. I will tell you about a model that was a 3D model that we received to obtain an infrastructure of spatial data.
Получение 3D-модель.
To obtain a 3D model, we selected a stereo pair with off-nadir angles of 2.5 and 11 degrees. We built a DEM with 2 meters spacing, and we overlaid orthophoto plan. In parallel, we created 3D vectors. We digitized bridges, trees, a lamppost, some shields. After receiving vector information, all of that was imported in a 3D module to generate a 3D model, and then we applied structures, photo structures to this resultant model,
Натягивались в модуль.
which were then overlaid in 3D mod, and this gave this nice picture.
Автоматически загружены.
Automatically we loaded special point objects like lamppost, trees, and this is the picture that we got as a result. Nice picture. In data interpretation, we looked at digital orthophoto plans obtained from Pleiades, Worldview, and A3 cameras. We used scanned topographic maps of 1 to 500 maps,
1/10,000.
vector map 1 to 10,000, and a catalog of topographic objects obtained from worldview 1, GOI, and Iconos. We analyzed 236 various objects needed to create 1 to 2,000, 1 to 5,000 maps. The main problems in interpretation were caused by small objects and the objects covered by vegetation. In analyzing accuracy from Pleiades and worldview and GOI3, we used orthogonal templates in 2 categories, that is multi-story city buildings and single-story private houses. We analyzed 40 houses in city buildings and 43 in private homes. So on this slide we can see ortho photos received from Pleiades, and on the right images obtained by A3 camera.
Полученные.
Then we further analyzed what we obtained and drew. We checked this against reference data. As a reference, we used A3 camera data. On the left, you can see ortho photos from Pleiades, and on the right, ortho photos from A3 camera. The maximum error range was 3 to 5 meters for single objects. The form and size of buildings is depicted correctly by Pleiades images, but there may be some difficulties involved with drawing some architectural details. In private houses, there are difficulties with separating residential and non-residential structures. The average error of angles for Pleiades and worldview is 1.3, 1.5 meters. The average angle error in stereopairs is better. All the measurements were summarized in one table, and you can see them here on the slide. We also assessed maximum allowable deviations for 2001 to 5,000 map objects according to regulations. From this diagram, it follows that the stereopair makes it possible to position objects sufficient for 1 to 5,000 maps. For contour lines, we used an open area with private houses, and for full visual control, we drew contour lines manually. All the data received was checked against reference data. I mean digital topographic maps 1 to 10,000 scale with 2 meter spacing shown in brown on the picture, and blue color indicates is the resultant picture. The overall form of the relief is shown correctly. The relief, the terrain is somewhat generalized. Hills of 3 to 5 meters are omitted. Perhaps if the angle from which image was made has been changed, we would have had better accuracy. The resultant 3D model is metrically correct and discrete. The discreteness of the model makes it possible to work with individual objects and assign attributes to them, meaning you can do 3D measurements. This model can be used for site visualization and for spatial solutions for urban planning. Pleiades can be used for 1 to 10,000 maps. With the stereopairs, you can also add this to a map of 1 to 50,000 between residential settlements. Racurs and Technology 2000 wish to express appreciation to Astrium for the data that they provided. Thank you for your attention.
No questions? So, just few words. I would like to thank you, Racurs, and the speakers for these studies, because it shows a very high level of expertise, which is not very common. And as well, I think that this study is especially very rich. The study shows that the RPC models provided by Astrium are quite good, even without any GCPs. And Racurs studied so much different configuration that is very useful to see the behavior of the RPC model with few ground control points, which is, in fact, must be very common in operational situations. So that's why, for me, this study was very useful and very interesting. So thank you again for this very important work.